Hello friends, welcome to my channel Academic Made Easy PC. Exercise 1.4. First question. Without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or non-terminating repeating decimal expansion, which I already taught you in the introduction part. I gave you a formula to find the decimal expansion and also a formula to check whether it is terminating, that is stopping decimal expansion or not stopping and repeating decimal expansion. So now let's see sums. So first question is 13 divided by 3125. For this we have to check whether it is terminating or non-terminating repeating decimal expansion. So we have to just check the denominator alone for this whole question. So 3125, we have to take the prime factors. So when we take the prime factors, we will get 3125. So 5 6 times, 2 times, 5 again, 5 5 1 2 5 5 2 5 5 5 5 1. So the prime factors is 5 power 5 into 2 power 0. If we don't have 2, we have to write it as 2 power 0. It means 2 power 0 is equal to 1. No? So only I have written like this. If the denominator is of the form 2 power m into 5 power n, for some m and n are non-negative integers, okay, for some n and m non-negative integers, we will get the decimal. So for some non-negative integers, we will have the terminating decimal expansion. Therefore 13 by 3125 has terminating decimal expansion. Decimal expansion. Okay, so now let's see the next subdivision. Second question, 17 by 8. So now we have to check only the denominator, isn't it? So solution. So when I take only the denominator, so 8 prime factor is 2 cube into 5 power 0. So therefore this is of the form 2 power m into 5 power n for some m and n non-negative integer. Therefore 17 by 8 has terminating decimal expansion. Okay, so now next question, 64 divided by 455. So now here also only the denominator. So when I take the prime factors of the denominator, 5 9 1, so 7 1 3. So I have 7, so I'll just stop it and say that it is having non-terminating repeating decimal expansion. Okay, so since I have the number other than 2 and 5, I'm saying that it has non-terminating repeating decimal expansion. Since 2 power m and 5 power n is not in the number 455, it is said that 64 by 455 is non-terminating repeating decimal expansion. Okay. So only 2 power m into 5 power n should be there, then it is terminating. So if 7, 13, 3 comes, means it is non-terminating repeating decimal expansions. Okay. Question 2. Write down the decimal expansions of those rational numbers in question 1 above which have terminating decimal expansion. So in the previous question we saw, no, all those we will be taking only the terminating decimal expansions we have to find. Okay. So I have taken only the terminating decimal expansions. Okay. So now we'll move on with the first subdivision. So that is 13 by 3125. We already saw 3125 prime factor is 5 power 5 into 2 power 0, isn't it? Now, if I take 13 by, I'm just writing this one, 5 power 5 into 2 power 0. So, I want here 5 power and 2 power should be equal. So, I have to multiply and divide in such a way that I get equal powers for 5 and 2. So, I will multiply and divide by 2 power 5 by 2 power 5. So that I will get 13 into 2 power 5 divided by 5 power 5 into 2 power 5. So 13 into 2 power 5 will give me 416. Okay, so 416. So then I will have 10 power 5. That is, taking the power common and 5 into 2 gives me 10. So that I will have like this. So that the decimal expansion for this will be 00416. Just write like this. Then you have to bring it in forward. Okay, so 1, 2, 3, 4 and 5. So I will have my decimal place here. So the decimal expansion for this will be 0.00416. Okay, so next subdivision is 17 by 8. So now we have to see the denominator. No, so 8 is equal to 2 cube into 5 power 0. So now I have to multiply and divide by what to get the powers equal? I have to multiply and divide by 5 cube. Okay, so I will have 17 into 5 cube divided by 2 cube into 5 cube. Okay. So 17 into 5 cubes will give me 2125 divided by 10 cube. So I will have 2.125 as the answer. Okay, so therefore the decimal expansion is this one. So next is third subdivision, 15 divided by 1600. So the prime factors of 1600 is 2 power 6 into 5 square. Okay, so now I will write 15 divided by 2 power 6 into 5 power 2. So to make the powers equal, I will be multiplying and dividing by 5 power 4 and by 5 power 4. Okay, 15 into 5 power 4 divided by 2 power 6 into 5 power 6, which will give me 9375 divided by 10 power 6. So therefore the decimal places which I will have is 7, 5, 1, 2, 3, 4, 5 and 6. So 0.009375. Question 4. 23 divided by 2 cube into 5 square. So directly it is given, so that we will write 23 by 2 cube into 5 square. So to get the powers equal, I will multiply and divide by 5 by 5. So that I will get 23 into 5 divided by 2 cube into 5 cube, which is equal to get 115 divided by 10 cube. So that I will have 0.115. So this is my decimal expansion. So now my fifth subdivision will be 35 divided by 50. Okay, so now I will have my denominators factors as 2 into 5 square. Okay, so now I will write 35 divided by 50 is equal to 35 divided by 2 into 5 square. So to get my powers equal, I will multiply and divide by 2 by 2. So that I will have 7 by 2 square into 5 square, which is equal to 70 by 10 square. So I will have 0.7. 0.70 also you can have, or else 0.7. Okay, so this second question also is over. Question 3. The following real numbers have decimal expansions are given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, then what can you say about the prime factor of Q? So question 1, 43.123456789. Okay, so solution. So we already learnt that if a decimal expansion is stopping, it means it is terminating. So terminating means it is a rational number. Only rational numbers will terminate. Since the decimal expansion is terminating, therefore we will say that 43.123456789 is rational. Okay, so they are also asking, and the form of P by Q, what can you say about the prime factors of Q? So we know that if it is terminating, we know that it will be of the form 2 power m into 5 power n. No, so the prime factors of Q will be 2 power m or 5 power n or both also. Okay. Second question, 0.120, 1200, 12000, 120000, etc. It goes on. And we also learnt in standard 9 that if these types of numbers are given, it means that it is non-terminating recurring. Okay, so this will not stop and it keeps going on. So therefore, it is a irrational number. Since it is an irrational number, we cannot write it in the form of P by Q. The third subdivision, 43.123456789. Solution. Since it is repeating, this bar represents repeating numbers. Okay, so since the decimal expansion is non-terminating and repeating, it is proved that it is a rational number. Okay, so now we have to see what are the factors of Q. Okay, so the factors of Q can be 2, 5 and the other number also. And other numbers also will have 2, 5 and other numbers also, but 2 and 5 alone will not come. Okay, so only it is repeating, non-terminating, repeating number. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.